Now, I thought it would be interesting to go through some actual investigations and walk through them with you to showcase what it might be like to use Splunk to hunt down and correlate events between multiple log sources or indexes during, well, a real incident. And I thought, what better way to showcase this kind of thing than to go through the boss of the SOC challenges hosted directly by Splunk themselves. And if you don't know what this is, well, the boss of the SOC, or the bots competitions, are hosted by Splunk and are designed to simulate real-world security incidents and challenges and allow us as analysts to practice our SIM investigation and threat hunting skills in a more controlled environment. And so we can think of this like a CTF or a capture the flag event, but for blue teamers. And what makes this super cool and practical for us is that they preload a giant dataset full of events from multiple systems and hosts and security appliances. And then within there are events and logs that correspond to the incident that we're tasked to investigate. And so it's super realistic in that way, and the competition itself will prompt us with certain things to find or conclusions to arrive to as we work through the incident. And in my opinion, like I said earlier, this kind of practical hands-on experience is the best way to get more comfortable with using a SIM and learning the various methodologies around searching and correlating. And I'll make a note here that every analyst is going to approach an investigation differently. And that's why I wanted to include this walkthrough, to show you my general process when going through this dataset, and the certain things that I think about or the questions that I ask. And so with all of that, let's dive right into the boss of the SOC. And again, this is a free resource that Splunk is kind enough to release, and the best part is we get a dedicated Splunk instance in the cloud. And so we don't even need to manually load in the dataset or use our VM. It's all just configured for us. However, if you really wanted to, I'll provide the link to this GitHub repository, which actually contains the data and the logs that we'll be dealing with for version 1 of this challenge. And so if you really wanted to load it in your own system or your own SIM, well, you can follow the guidelines in this repository. However, we don't even need to do that, and so we can just head to bots.splunk.com, where we'll be asked to sign in with our Splunk account. And if you made it this far in the section, well, you likely already have a Splunk account from when we were actually deploying and installing Splunk locally. And so I'm just going to sign in here. And once we're in, you'll see there are a number of different data sets. And so specifically in this case, we're going to focus on the boss of the SOC version 1. There are also additional versions of the boss of the SOC, so there's a V2 and a version 3, which you can find on here I think somewhere, but the GitHub repositories containing the datasets have been released, and so I'll include those in the links below. Again, just for that additional practice if you want to do some more, well, you'll have these available to you as well. And so under Play Now here, I'm just going to click on the boss of the SOC version 1. Alright, so now we're in. And when you load in, you're going to see this timer here in the top right. And so don't really worry about this. If you run out of time, you can just start it over, so it's not really a big deal. And you can see there are two different scenarios here. You can see that the first scenario here, or the first incident, is going to be a website defacement. And the second one is going to be ransomware. And so for now, let's start off with scenario 1. And so when we hop in, well, you're going to see this following scenario here that Splunk has built up for this incident. And so feel free to read through this briefing if you'd like, and check out the various details and artifacts that are listed. But basically, on our first day in the SOC, we're tasked to investigate the website I'mReallyNotBatman.com, hosted by Wayne Enterprises. Because there have been some reports that it might actually be compromised by the famous Poison Ivy hacking group. And so our job now as Alice is to determine if the site was indeed compromised and defaced. And so did a malicious actor exploit some sort of vulnerability and take control of the website and actually modify its contents? And just under this, well, you can see we have the link here to our actual cloud instance of a Splunk server. And so if I click on this, we're going to be brought to the login page for this cloud instance, right? So we didn't have to deploy this on any of our local machines. It's just already here on this URL. And so we can copy the username or the credentials here, so username and password of user001-splunk. So I'll paste that in here, as well as the password of splunk.5. And so I'll just paste that in and we should get logged in. All right, and now this is looking a bit familiar, right? And so this is just like what we've been using. This is Splunk Enterprise, but it's in the cloud, and we can just interact with it the same way that we typically would. And so under this section, well, we're going to have a number of leading questions or guiding questions to help us walk through the incident investigation and response. And so there's quite a bit for us to go through, as you can see. But what we really need to do first is to sort of get a handle on what data or indexes that are available to us, which is going to determine our searching and correlation capability and our overall strategy. And so let's hop back over to our cloud-hosted instance of Splunk. And again, this is great. We don't need to do any configuration or deployment or installation. It's just here and ready for us to access. And now, the first thing we want to do when we encounter any new Splunk instance, or when we're working with data we're not familiar with, is to understand what indexes have been, indexed within Splunk, and what kind of source types we have available to us as well. And to do that, we can use the event count and the metadata commands to list out all of the indexes, or hosts and sources, and source types within our system. And so first, what I'll do here is run the following query to pull back the list of indexes. And that's just going to be a pipe here into the event count command. And then I'm just going to turn off the summarize argument and set that to equal false. This parameter basically just tells the command not to use any summary information, just so we don't happen to miss any details. And then I'm just going to point it to any index. And if you remember how to do that, well, we're just going to use a wildcard. And this event count command is basically going to count the events per index. And again, it's a useful way for us to see how many events are stored in each index. And so if I run this, well, we can list out all of the indexes on the system. And so we have some under main here, but what I'm really interested in here is the bots v1 index. And this is where all of our data is going to lie. And we have quite a few events to go through. And we could have just read through the documentation and knew that we should be using the bots v1 index, but I just wanted to show you this command as it's pretty useful in use cases where we don't have this information in the field. And so next, let's look at the various source types that we have available to us. Right, so we have this main bots v1 index, but within this simulated network, well, we have logs flowing in from a number of different sources, like endpoints or servers or networking equipment and security appliances. And so let's list out the scope of what event sources or logs we have to work with and correlate. And to do that, I'm just going to back out this command here and run a new search, this time using the metadata command. And I'm going to set the type to source types. And then pipe this over to fields and just grab source type. And the fields command basically allows us to tell Splunk to only include the source type field in the output and filter out any other fields that might be included by default. And so I'll just run this. And you can see here we're getting 23 different source types. And so we're getting some Windows event log events, which is nice. We're getting some registry events as well. And so this might be good for identifying things like installed services or persistence methods. We're getting some sysmon logs as well. And so it looks like we have some good endpoint visibility. And then we have some FGT events, or traffic, or UTM. And if you just look up the name here, well, you'll find that these refer to event logs from FortiGate devices. And so these are going to be firewall logs. Specifically, this third one here, or UTM, is the FortiGate Unified Threat Management logs. And so this is going to give us information about intrusion detection and prevention, or even things like web filtering, like a web application firewall, that kind of layer 7 telemetry. And so for a website defacement incident, well, this could be super useful to us. Remember, we're always trying to put the visibility that we have into the context of what we're investigating, so we don't go down any unnecessary rabbit holes. We have some logs from IOAs, so this could be the web server itself. Some events from Nessus scanning, and so Nessus is a vulnerability scanner developed by Tenable. And so we might be able to identify some website or web server vulnerabilities that we can correlate any exploits that an attacker might have ran or attempted. You can see here at the bottom, there's also some stream data. And so stream usually means PCAP data, so events going over the wire or over the network. And so we have streams like DHCP, or DNS, or HTTP. And at the very bottom here, you can see a Suricata log. And so just like with Snort that we looked at earlier, Suricata is a widely used open source IDS. And so it can also inspect packets and create alerts based on signatures. So these logs can also be really useful. And so now that we have a better idea of what's going on and the type of visibility that we have over the environment, well, let's jump into investigating some of these questions. And so I'll just scroll down here to the first question. And what I'm going to do is put it in this table format so I can actually read some of the questions. No, I think I have to open it. Okay. So this first question here, what is the likely IPv4 address of someone from the Poison Ivy group scanning I'mReallyNotBatman.com for web application vulnerabilities? And so funny enough, this kind of reminds me of our Apache example from earlier, where an attacker was scanning the website before attacking it. And this is very common to see. When we think about the stages of an attack, which we'll touch on more in the threat intelligence section, but often these kind of attacks need to start with some sort of reconnaissance to discover information about the target. right? So collecting what type of web server is running, or what version, what applications are running on it, or any employee or users that can be enumerated, that kind of thing. And also cross-referencing that recorded information with any known vulnerabilities of any of these systems. And so when I'm thinking about identifying things like reconnaissance against a web server, well, I want to think about what source types we have available to us, and what types of those would most likely contain relevant data, or indicators of, say, a scan. And so, what might be useful here, right? If they're scanning the website, it means they're sending in inbound packets towards the web server, meaning it's going to be a network-based event. And so if we have some sort of firewall in place in front of the web server, or an IDS or IPS sitting in between, or on the endpoint, well, these are appliances that might actually be able to detect and block this kind of activity as well. And so what I'm thinking about here is the HTTP stream logs, the firewall or the FortiGate logs as well, and also the Suricata logs. And we can most likely find the same answer using any of these methods. Again, every analyst can approach something differently and still achieve the same result. Cool, and so let's start our search. And so first, let's make sure that we're searching through the appropriate time range. Remember, it's usually not best practice to query everything from all time. And so within the incident briefing document, well, we can come to find that this incident took place within the month of August 2016. And so what I'm going to do here is go down to date range and change this to between. And so what I'm going to do here is paste in the starting date of August 1st, 2016. Then I'm going to paste in the end date of the end of the month here at August 31st, 2016. And then I'm just going to hit apply. All right, and so let's first start out with the FortiGate logs or the firewall logs and see what we can come up with. And so first, I'm going to set the index here to bots v1. And next, I'm going to set the source type here to equal any one of these FortiGate logs. And so to do that, I can just type in FGT and then put a wildcard, right? Because then we can match all three, event, traffic, and UTM. All right, that looks good to me. And because we know the domain of the website, I'mReallyNotBatman.com, well, let's include that as one of our search keywords, just so we're not pulling back too much irrelevant information. All right, that looks good to me. So let's run this. All right, so we have almost 14,000 events within this time period that match our criteria. And so we can open up any event here and basically look at the different fields that we have. And so we have things here like source IP. We have things like the action, right? Because these are firewall logs, well, we have things like, is the traffic allowed or was it denied? We have things like the destination or the ports involved. Oh, under here we have the URL. And so that's really cool, right? We can see what the actual URL is on the page that's being accessed through the firewall. And so, there's a couple things we can do here. We can take a look at the top values for the source IP address, right? And so nice, we only have 2 IP addresses here to really look through. And we can sort of see by the count here and the percentage differentials, well, this 40.80.148.42 IP, well, it's taking up a majority of our traffic, so that's kind of interesting. It's not explicitly definitive on its own, but it is an interesting finding and sort of prompts some more investigation. Since this is a firewall, and we have that action field, well, let's look at what the available actions are, or the ones within our results. And so we can just click on the action field and open up the top values. And so you can see, in this case, we have allowed, blocked, and deferred. And so since we know that the attacker was running some kind of vulnerability scan, well, it's probably a safe bet that at least some of those packets might have been blocked. And so let's add this field and this value to our search. And so we can just click on the word blocked here to automatically add it, but just for verbosity's sake, I will type it out here. And so that's just going to be action equals blocked. And I'll just make sure to put that in quotes just in case, and we can run that. All right, there we go. So we cut it down to about 4,000 events now. And when we look in the source IP address field, it looks like we only have one result. And again, yeah, it's that 40.80.148.42 address. So that seems to be the only IP address that's getting blocked. And so again, we're adding on to this suspicion and helping us make some judgment calls. And so while we have 4,000 events, let's try to open up one of these fields and see what we have available to us. Oh, okay, awesome, nice. And so we can basically immediately see here that under the attack field, that this action was blocked because it identified a web vulnerability scan from the Acunetics software. And Acunetics is, again, a vulnerability scanner similar to Nessus or Qualys, and that it can be used to probe an endpoint and find out any vulnerabilities or flaws that can lead to exploits. And so often this kind of tool is used in vulnerability management, which is slightly dipping into that more GRC side of cybersecurity where, again, you have folks that regularly scan an organization's resources to make sure that they're all patched and that there are no major vulnerabilities out in production. And so again, it's possible that this could have been done legitimately, and maybe the vulnerability management team didn't tell the sysadmin or the SOC to allow that Acunetics traffic through, and so we're getting a bunch of denied traffic here. But I think it's fair to say that this is probably our attacker scanning the website. And under the attack ID field here, well, I can just Google this number. And when I do that, well, we can see this reference coming up. And we can see that this type of alert or drop action occurs when the FortiGate firewall detects an attempted scan from the Acunetics vulnerability scanner. And so I'm going to go with this IP address here, this 40.80, for our answer for this first question. And so I'll just paste it in and hit submit. And there we go. Okay, so we finally got the first question. And under host here, well, I also want to grab this IP, so I'm going to copy this as well. Because it's clear that this is the IP address of our web server, or I'mReallyNotBatman.com. And so we can sort of start painting that network diagram in our head. Now, how else could we have solved this? Well, remember, we could also use the HTTP stream logs, or those packet captures. And so let's change our query here to pull back that HTTP stream data. And so that's going to be stream:/HTTP. And to make sure we're not pulling back tons and tons of events, well, let's just search for the keyword of our IP address, that internal 192.168.250.70, or the IP address referring to I'mReallyNotBatman.com. Because I'm not quite yet sure which fields we might have available to us, but I do know that I'm looking for traffic or packets coming to this IP. And so I'll just run this search. And wow, okay, so it looks like we're actually capturing the full HTML markup, like the whole content of the web page, within these raw packets. And that's super cool, but that's a lot of information. And also, unless you were doing some sort of SSL stripping, this kind of thing is less common these days. It would be a bit harder to get your hands on the actual raw HTTP packets, where everything now is using TLS. However, let's open up one of these events and take a look at the actual details, or the fields that we have available. And so it looks like we have the source_IP field, and so that's what we could use, right? And so if I go under source_IP here, well, we're listing out some more IP addresses, but at the top value here, again, we're seeing this 40.80.148.42 address. Or what I could do is just add on to this command here and run the top command to limit, say, the top 5 values for the source_IP. And again, same kind of deal here. We're getting the same information. At least we're getting the count. And so we can see again, there are a ton of packets coming from 40.80. And so let's click on this IP address to view its events. And so this is going to change up our search for us automatically to indicate the source IP field that's equal to 40.80.148.42. And I'm just going to look at the interesting fields here. And let's open up the HTTP_user_agent field. And we can immediately see some interesting or weird-looking user agents. And these appear to be instances or attempts of command injection. And so we can see some template characters and reference to Unix commands, right? We can see NSLOOKUP here. Or the print command, so maybe this is PHP or Python or something. However, we can see the word Acunetics here as well. And so from experience, this is likely the vulnerability scanner probing the website to see if there are any injection vulnerabilities by using injection strings within user agents. Cool. If I keep scrolling down here and click on the URI_path, well, we can see some references to Joomla, which is a content management system that the web server is likely running. But under this, it appears to be there's some sort of path traversal or LFI attempts. And it's trying to pull back the win.ini file, I guess as kind of a proof of concept that there's an inclusion vulnerability. And we can see all these // strings. And we could look at so many other fields as well too, right? We could look at the cookies, Okay, we're getting some Acunetics weird cookies here. Maybe trying to do some sort of overflow attack. Or we could look at things like the form data, but honestly, I think it's fair to say that this is the scanner, and again, the same IP address of 40.80.148.42. And so lastly, and again, I just want to be super verbose here, which is why I'm covering all these methods, we could have also used the Suricata source type as well, right? And so if I change this, so instead of stream HTTP, we run Suricata, in the same way that we were able to identify those denied or dropped packets from the firewall, well, Suricata was likely also able to detect this kind of scanning activity using its signatures, and it probably created some alerts. And so let's try to pinpoint some of these scanning alerts. And so I'm just going to run this and also include I'mReallyNotBatman.com as a keyword. Alrighty, and already I can see the alert.signature field. And so let's take a look at these. Ah, okay, and there we go. So we have a ton of alerts related to cross-site scripting, or XXE, or SQL injection, and even references to different CVE numbers as well, which is likely to see with a vulnerability scan as it attempts to probe and check if these vulnerabilities exist. It also looks like we have the source_IP field again. And so let's try to correlate the two. Let's build a table that correlates the top source IPs and the count of alerts that is associated with them, right? And so what we can do here is just add on to our search, and I'm just going to run the stats command to count up the events by source IP. And then I'm going to correlate that with alert.signature. And so I'll just run this. Cool, and so we're pulling everything back, but what we can do now is just sort this by the reverse count to pull everything up, and then we can just run the head command to pull back the top 10 events, or the top 10 counts. Nice, and so again, it looks like we have this same 40 IP address, which is a common culprit for generating a lot of these alerts. So we have 103 here, related to, cross-site scripting and SQL injection. And so again, it's fair to say that this is our attacker or our scanner. All right, so let's hop over to the next question here. What company created the web vulnerability scanner used by Poison Ivy? And so we already answered this with the previous question, right? We discovered, I don't know if it's here, but we did see it basically everywhere that it's using Acunetics, right? We were able to see that in things like the firewall alerts or the actual user agents themselves. And so I'll just type in Acunetics here and hope we're right. Yep, there we go. Okay. So next, what content management system, or CMS, is I'mReallyNotBatman.com likely using? Funny enough, we also answered this question as well, right? And so often content management systems like Joomla or WordPress will have different signatures or fingerprints that define them based on their URL structure. There are other things as well, like the host headers and cookies, for example. But for example, WordPress has a lot of website paths like WP-content or WP-includes. And in the case of our logs here, let's hop back over to, I think, when we were looking at the web or the network-related source types. And so what I'll do here is change our source type here back to the FortiGate logs. And what I should do is just type in I'mReallyNotBatman as our keyword. And what I can do is just look for that URL field or that path field. Okay, we can use vendor_URL, I think. Yeah, there we go. Okay, so we're getting a lot of references here, again, to /Joomla, which is probably the base or the root index that's hosting whatever Joomla website or blog that this is. You can also find this out, I'm sure, by looking at the HTTP stream logs as well. Since it's recording the entire markup and response from the web server, well, we can probably find it even easier there. Actually, let's try that. So I'll just change the source type here to stream:/HTTP. I'mReallyNotBatman.com. I should stop deleting that. And I forgot an R in stream. And so let's just open up an event here. Okay, maybe not here. Maybe not this one. But we should have different fields that can be useful here, like the URI or the URI path. And so again, we're seeing more references to Joomla. Cool. All right, and so let me just put in Joomla here for the answer. Nice, there we go. And so next question here. What is the name of the file that defaced the I'mReallyNotBatman.com website? Okay. So now we're moving away from the more reconnaissance phase of the attack and into the exploitation phase, where the attacker is actually loading in malware or compromising the website in some way. And so let's actually skip this question for now and come back to it, because I think we might need some more information first that relies on it. And so let's go down to this question here. So what IPv4 address is likely attempting a brute force password attack against I'mReallyNotBatman.com? Okay, so cool. We kind of did this with our Apache logs as well. And so again, let's look at the firewall logs for this. Because again, it's going to be that network traffic data. We might be able to catch this with some of our firewall rules. And so what we can do is just type in FGT here for FortiGate with a wildcard. And again, put in I'mReallyNotBatman.com. And from here, well, again, we could look at the blocked or dropped traffic again under action, but I want to get a list of all of the IP addresses that were interacting with this web server. And so I'm just going to do a simple count of the IPs. And so that's just going to be the stats command to count by source IP, I think it is. Yep. All right, and so it looks like we just have two results. And so we have the one that we identified earlier that was doing the scanning of the website, and so it's probably a likely contender that the same IP address could be doing the brute forcing. However, let's take a look at this other IP address as well. And so let's use this IP to search across the rest of our sources, or our source types, to see if we can pull back anything related to this IP address. And so what I'll do here is just change up our command a bit to, I'm still going to search for I'mReallyNotBatman.com, but I'm also going to paste in this IP address. And then change our source type to basically anything. Because by opening up the source type to anything, well, we're trying to match against anything related to our site, but also with this IP address as well. And the reason why I'm doing this as keywords is, again, I'm not sure what fields we'll have available to us. And so, with that loaded in, let's see what other source types we have. Okay, so as expected, we have the Suricata logs, the FortiGate or the firewall traffic, specifically the unified threat management, and our stream data or our packet capture. So what else can we look at? So let's look at what actual paths or pages on the website were being hit. And so what I can look for here is URI. Okay, so it looks like it's just hitting this index.php page under the administrator directory. And so it's possible they could be trying to log in. Since, with sites like WordPress that have wp-admin, well, the index.php page here under the administrator directory is the actual administrator portal in Joomla websites. Or if you're not logged in, the actual login page. And so I'm going to click on this path to add it to our search. And you can see we've cut down to about 1,000 events here, which is nice. Now, what's really interesting to me here is this form data field, which might actually include the post data or the parameters, like the body content included with the post request, which, as we can see here, in the case of a login, would include parameters like the username and the password. Where is it? Yeah, the password. And so again, this is another reason why this information won't likely be logged in the field, or why it's encrypted these days, because we don't really want these passwords to be stored in our logs. But what do you know? So it looks like we have a number of username and password combinations within the post data here. And so let's start listing these out. So what I can do is change our search up a bit here. And I'm just going to run a stats count to pull back anything in that form data field. Yep, and there we go. So this is a clear brute force attack, right? We can see under, where is it? Username. So we're seeing a bunch of admins for the username. And then under the password parameter, well, we're seeing a bunch of what look to be password attempts, right? So we have Arthur and Flower, 777, Fire, Baseball. And so this IP address is our likely culprit that's running all of these brute force attacks. So I'm going to paste that in here, and we should have the right answer. There we go. All right, next. What is the name of the executable file uploaded by Poison Ivy? And so this actually isn't so bad, right? Because we know what kind of visibility we have And we know we can see things like the different GET and POST requests to the web server. And we also know we can see things like the URLs and the paths. And although we might not need it, we can also see things like the actual HTTP packet streams as well. And so let's look at all of our source types again. So I'm going to delete all of this, and there we go. And when we're thinking about behavior now, right, so these behavioral indicators, after gaining access to the administrator dashboard on the website, assuming this brute force was successful, well, the attacker, often in these cases with content management systems, will upload some sort of file, like a web shell or a reverse shell, so that they can compromise the underlying web server. And so along with our search here, let's also look for any keywords that match the file type of .exe for executables, right? And so what I can do here is add another parameter. And again, there's going to be like a hidden and between our different keywords here. And so I can run .exe, and then before this, I can add in a wildcard. And so if I run this, okay, so we have 86 events. And that's super telling, right? Because why would there be any executable downloads or uploads to this server? And it could be benign depending on the business and the use case of the website, but in the briefing, apparently this is a blog, so that's very interesting to see. And so as I scroll down here through the results, oh, okay, so this is pretty interesting, right? We can see some odd characters. But in reality, I can see, I might need to zoom out. So I can see the content type here of application octet stream. And beside that, I can see the file name parameter here that's set to 3791.exe, and that's what we're actually matching. And so this doesn't look good. We have an executable file being uploaded to our server. And so this could be the answer, right? But again, how else could we do this? Well, file uploads to web forms are going to use the HTTP POST method. And so what I can do is look for that field somewhere in here. So there should be some sort of method field. Yep, there it is. HTTP_method. And what I can do is just set this to post just by clicking on it, right? And that's going to update our query. And we only get 7 events returned. And so this is super nice to work through, right? We could even just do this manually if we really wanted to. However, let's look at the different fields that we have available to us. And I'm looking for anything related to files. Okay, so we have file size, file state. Okay, file info looks good. Oh, file name. Okay. And so we can see 2 results. And so we have this weird named file here, which is also an executable. This could be some sort of temporary file that was stored on the web server. But again, we also have this 3791.exe file here. And so what I can do is click on this to add it to our search. And yeah, we just get the 1 event here. So I can open this up where we can see that it's a Suricata alert or a Suricata event. I don't think it's an alert. And it's coming from that 40.80.148.42 address. And so that's even more telling now, because this was the IP address that was performing the scan. And so what I can do now is just zoom out quickly and use this file name as just a keyword. And then I'll remove this and this as well. And there we go. So I'm just going to run this. And we have 4 events that match, 3791.exe. And under the source type, well, one of them is from the FortiGate logs. So I'm going to click on that to open it up. And I can already see it here. File is infected. Where's that? There we go. So under the message field here, we have file is infected, which is not a good sign. And also, I think I saw at the top here, we have the file hash field. And so this looks like a SHA-256 hash related to the actual, 3791.exe file. And so really cool, right? So what do I do whenever I see a hash? Well, I want to copy it and I want to upload it to VirusTotal. Remember, we're in the investigator mindset here. So what would we do if we got our hands on a suspicious file's hash value? And so on VirusTotal, just going to go under search here and paste it in. And well, that doesn't look good. That's a lot of red, right? That is a very high rating of flagging this file as malicious. And interesting, we can see ab.exe here under the file name. And that kind of looks like the Apache benchmark utility that is kind of familiar, right? And so this is probably a Metasploit reverse shell, just like the one that we created in the endpoint section. And in fact, some of these tags actually point to it as well. And so it looks like this is our answer. So I'm going to copy the name of that file, head back over here, and paste in that file name. There we go. And this next question, yep, I figured that was coming. What is the MD5 hash of the executable file uploaded? And so we just got the hash value here from our FortiGate logs. However, this is a SHA-256 hash. And so you might not know what to do in this case, right? We have one file hash, but how can we get a different file hash if we don't have access to the file? Well, sometimes when we look through a malware database, like VirusTotal, for example, and this is getting into some threat intelligence stuff, which is really cool, but we can go under details here. And what do you know? We can see some other hash values, specifically MD5. And so we can see if this file from our SHA-256 hash has been associated or linked to any other, file hash like MD5 or SHA-1. And so that should be the answer. So let's copy this and paste it in to see if we got that right. And we did. All right, doing good. So now let's go back to some of the previous questions that we skipped. All right, so what is the name of the file that defaced the I'mReallyNotBatman.com website? And so the way I interpret this is that the attacker uploaded some sort of file or page to the website that I guess was the, referred to as the defacement. They didn't actually change any existing contents. It looks like they just uploaded their own file. And so let's remember what we have available to us and what we might want to look for. And in this scenario, what we want to look for is either a post request, right? So where data is being sent over to the server, because if they uploaded a file, well, there's going to be a post request in there. Or some sort of GET request where someone is retrieving or asking to retrieve data or a page from a web server. And so in other words, either a post request from one of the attacker machines or a GET request from the web server to one of the attacker machines. And so what I want to do is look at anything in our logs with the destination IP address of our web server. And if you remember, we wrote that down earlier. And so that's going to be source type of any, and then dest IP here for destination IP of 192.168.250.70. Now, we're going to get a lot of events. So what we can also do is narrow this down farther to just the two malicious IPs that we identified. Remember, there was one that was performing the scan, and then the other one was performing the brute force. And so what I can do here is and source IP, or source underscore IP, of 40.80.148.42, or, because remember we want to match either, we want the source IP to equal, and I missed an equal sign here too. We want that to equal 23.22.63.114. And so let's try running this. We should cut down the results. Okay, not bad, 251. And so because we're mixing in a number of different source types here, our interesting fields are going to be kind of a bit all over the place, but that's okay. So let's first look specifically for any GET requests. And so to do that, remember we had the HTTP underscore method field. There it is. And so what I can do is just click on GET here to further narrow down our results. And now if you recall from before, well, we leveraged the file info event type from Suricata when we were looking at that malicious executable. And so let's try to use that again. And so if I find the event type field, there it is. Yeah, and so we have one result for file info. So let's definitely look at it, right? And so again, as suspected, it's from Suricata. And if I open up this field or this event, well, we can see under the host name here, this is quite interesting. We have prankglassine.bracket.jumpingcrab.com. Okay, never heard of that before. And if we go down to the URL here, well, we have poison ivy is coming for you, Batman.jpg. And interesting, if you look at the source port, well, we have 1337 or LEET. And this is definitely an odd port number to see within website traffic. And 1337 or LEET here, LEET speak, is similar to Quad 4, wherein that in the hacking world, it's sometimes used for malicious purposes to, I guess, be funny. But again, literally any port could be used here. I think this is just Splunk throwing us a bone for the CTF. And again, while this is a little whimsical here with this Batman theme, I think we can infer that this is an interesting image file, specifically by the name here, that's being accessed by the attacker onto the web server. And so I'm going to assume, and I think it's safe to say that this is the file that was uploaded. So let me try to paste this in here. Have a bunch of white space. Clean that up. No? What if I remove the slash? Yeah, there we go. I did not read the answer guidance. Cool, okay. So the next question here, this attack used dynamic DNS to resolve the malicious IP. What fully qualified domain name is associated with this attack? And so basically, dynamic DNS is a service that helps keep a domain name linked to the current IP address of a server or device, even if that IP address changes all the time. And so why that's important is because attackers will sometimes use dynamic DNS solutions, or I would rather say often, so they can change their IP address frequently, but still have, their tools or their callbacks reach a single source, like their domain name. Right? And so an attacker often has to change their IP address to be anonymous, or to get around block lists. They can simply just get a new IP address and have the dynamic DNS update their domain to point to that new IP. And again, this is also useful for command and control servers as well. And if you remember, when we were investigating this previous question, we came across this interesting hostname of, whatever.jumpingcrab.com. Now, this is interesting because it's listed under the HTTP hostname, and so it's coming from the attacker's side, which is just odd for this kind of request. And so on Cisco Talos, I'm going to paste in that domain. And again, if I just do our domain checks, our domain reputation checks that we've done so many times now, well, we can see that this base domain of jumpingcrab.com is untrusted. It has an untrusted web reputation, and it's been added to block lists because it's categorized as, malicious sites or malware. And if I just do a Google search of this domain, well, I come across this page from the Open Threat Exchange. And the Open Threat Exchange is a crowdsourced threat information sharing platform. And so this is really cool. We're even getting some threat intelligence baked into this challenge. And so we can see right away, if I zoom in, that the verdict of this domain is, a dynamic DNS service. And so I think that's going to be our answer here. So I'm just going to copy the whole host name here and paste that in. There we go. All right, and so what is the next question? What IPv4 address has poison ivy tied to domains that are pre-staged to attack Wayne Enterprises? Whoa, okay, so this is interesting. I think we can also use the Open Threat Exchange to answer this question as well. And apologies, as this is kind of taking us outside of the sim world, but it's realistic, right? And it goes to show how investigations aren't just limited to a single tool or function. And so to answer this, we have to think about the malicious IPs that we've already identified. Right, and so we have the 40.80 address that was doing the scanning and also uploaded the file. And we have 23.22, which also uploaded the executable, but also did the brute force. I think I got that the right way around. But anyways, what we can do here is head back to the OTX or the Open Threat Exchange. And at the very top here in the search box, we can paste in different indicators of compromise, like IP addresses or domain names. And so I guess the most likely culprit to start with would be that 23.22 address. So I'm going to paste that in here and see what we get. And so if we scroll down to passive DNS here, we can identify some host names or domain names that are associated with this IP address. And if we look at them closely, this looks like a typo squatting attack, right? So we can see WAN Corp here without the Y, or here without the P. So we have Wayne Core Inc. We have a number of different omissions here, which are clear indications of an attacker trying to spoof the Wayne Corp Inc. domain. And so these are probably pre-staged domain names that the attacker group has registered to set up some sort of phishing campaign, for example. And so the IP address in question is, again, that 23 address. So I'm just going to paste that in. Is that really the answer? Yep, it is. Okay. All right, we are doing pretty well here. I think we have all of these. Yep. So there's still a few. We might not get to every question here, just because it looks like some of these are going into the threat intel area a bit too hard. So maybe we'll return to them later. Yeah, and so I'm going to skip these two here because, again, they're more so getting into that threat intelligence research. And so maybe we'll return to this in the threat intel section, but also feel free to just tackle these yourselves, right? They're not too hard, it's just not really in scope for what we're doing. And so let's go to this question here. So what was the first brute force password used? And it looks like a number of these questions revolve around the brute force attempts. And if you remember, we were able to identify this earlier, so this should be pretty easy for us to tackle. And the way we did that, I believe, is we were looking at, well, let me just type in the domain. And we were looking at that specific URI path that leads to the index page under the administrator directory. So what I can do is just search for the URI underscore path and set that to equal to /Joomla /administrator /index.php. Let's try running that. Okay, so we only have around 1,000 events, which isn't honestly too bad. And so let's look at some of the different fields. And I think I remember from seeing before under this, again, we're under, I think we only have this HTTP stream data here. And I think under this, there's a field for form data. So, because again, if you're submitting stuff to a web page in a post request, you're going to be sending over parameters like your credentials within, form data. Oh, and there it is. It was at the top the whole time. Okay, so we have this form data field. And I think, yeah, we were looking at this before. And so, and again, keep in mind that the type of data that we're going to be looking at here, like the username and passwords, is commonly not available anymore. And that's mostly due to best practices, right? In the sense that we don't want to be logging user credentials within our SIM. But what we're going to look at here is, again, the URL encoded passwords submitted within the post data parameters. And so what we're looking at here is the form data field. And among other things that it probably contains, as you can see here, looks like there's a lot of URL injection attempts. But when we had this narrowed down to the IP address earlier, well, it contained all of the password brute force attempts with the username parameter and the password parameter. And so what we can do is use this to our advantage and include it in our search. And so I'm going to click on events with this field here to add it to our search, just as a wildcard here. However, what I want to do is specifically look for the password parameter. And so within wildcards here, I'm just going to search for pass. Okay, there we go. So if I look at the field now, yeah, there we go. So we're starting to see the username parameter and what looks like the password parameter, but it's passwd. So I can modify this a bit to be passwd. And we had the and symbol in front of it because, again, it's a URL parameter. However, I deleted that wildcard, which I shouldn't have done. Cool, okay. And so we've cut down to 413 events. And so that's probably how many, brute force attempts there were. And so now I want to make our lives easier for these next couple questions as I can sort of see what they're asking and do something a bit more advanced that we didn't cover yet. But what I want to do is actually extract this username field and this password field into their own, columns and set them up in a table so that we can then filter and sort through them individually. And to do that, well, again, I haven't introduced this yet, but we can use the rex command, which stands for regular expressions. And so we can sort of think of this like pattern matching. And so what I'm going to do is, run the regular expression command and look for the field. We're going to point it to the field of form data because that's where we're going to actually be extracting or pulling strings from. And then when it comes to what we're actually pulling out, well, I'm going to wrap this in quotes. Well, I'm going to look for that passwd parameter to look for that literal string of passwd. Because remember, we can see that here. And we can see it's set to equal, and then we have the value. And so the syntax for this is we can set this to equal again, and then we can put our value within these parentheses here. And this is where we can actually write out, our regex. And so it's going to be a, don't worry about the syntax here. This isn't really going to make sense. We don't really have time to get into, regex 101. But you can actually go to regex101.com if you want to learn how to use regex and write out different patterns. And I'll have that link down below. But basically, what I can do is put in the name of the column that we want to extract it to. And so I'm just going to call this password. And this is going to extract the actual password that we find in each event and put it into a column called password. And then what I'm going to do here is add this little string at the end here, which is going to match one or more word characters. And so anything like letters or digits or underscores, which typically make up a password. And so with this, I'm just going to hit run. And now we're getting the same results, but we should have an additional field here. Yep, there it is, called password. And now we're just extracting the individual passwords that we found within those fields. Cool, right? So what I'm going to do now is extract the usernames. So I'm going to copy the same line basically and just change this to equal username. And then change the actual column name to, again, username. And we should be good to go. Nice. And if I look under our new column or our new field here, called username. Oh, okay, so it looks like admin was the only username that was used for the brute force. And so with this, with these columns extracted, well, we can make a table out of them, right? So I'm going to run a table here. I'm going to pull the time field. So again, we want the actual timestamp. I'm going to pull the username, and then, of course, the password. And there we go. We've done it, right? And so to find the earliest or the first password attempted, well, we can just click on this time field here to reverse the order, right? So we ended, I guess, at 48 minutes, and it started at 45 minutes. So that means the first password attempted was 1234567 That's a pretty good password. Looks like this is probably the rock you word list. And so 1234567 was there a 9? Nope, 78. Cool, there we go. So we got that right. Next question. One of the passwords in the brute force attack is James Broadsky's favorite Coldplay song. We are looking for a 6-character word in this one. Okay, see what they're doing here. So what we want to do, I could probably just guess yellow here, actually, because that is a Coldplay song. Yep, there it is. However, how could we have found this out? Specifically, how can we pull back those 6-letter passwords? So to do this, what we can do is run the eval command. We're going to need to run it in front of our table. So I'm just going to make a new line here and run eval. And the eval command, again, haven't really introduced it yet, but it's one of those more advanced commands that we can use to create our own new field within the data that can evaluate various expressions. And so the new field I'm going to create is just called length. And I can set that to equal the length command, or len, and then feed it in our password column. So if I run this, we should have a new field here. No, we won't, because I did not add it to our table. And yeah, so we called that length, so I'm going to match it up here. And again, we're passing into this length command, or this function, the actual password column that we generated from, regular expressions. And so what this is going to do is count the actual characters within each of these, passwords. There we go. Okay, so now we're getting the length of each individual password. And so now that we're getting that, well, we can search specifically for those 6-character letters, or those 6 characters, before we build the table. And so what I'll do is just run a subsearch here, or a search command, and look for any length here that equals 6. There we go. So now we're just pulling back those, 6-letter passwords. And we're still getting 214. And so I guess we could go through these and try to, maybe use some open source intelligence here, or OSINT, and figure out, what one of these words could be a Coldplay song, but, the answer is going to be yellow. And so that's kind of, I guess, what they were trying to showcase with this question. So we don't really need to start listening to Coldplay songs. Not really my favorite band, but anyways, next question here. What was the correct password for admin access to the content management system running I'mReallyNotBatman.com? Okay, interesting. So we can probably use some logic here, right? And so if an attacker is doing a password spray attack and gets a hit, or like a successful login, well, they're probably not going to keep trying, right? And so we can infer that the last password in the list here, or the most recent one, is probably the correct password. And so what I can do is just take out, take out the length here. We don't really need, actually, it doesn't matter. But what I don't want is this search command. So I'll take that out. So we're just, running our basic, extraction that we just did. And then I want to find the most recent event, which is going to be this one. And so the password is Batman. Of course it is. And if you didn't catch that, it's because it's the most recent, event in the list. And so if an attacker is brute forcing all these passwords, and then they try out the password of Batman, well, their tool is going to tell them, hey, you got a hit, you got in. And so why would they keep, trying to brute force, basically? Okay. What was the average password length used in the password brute force attempt? Interesting. Okay, so we're going to get into some math and calculations here, which fortunately we've looked at the stats command before, but I don't think we did enough to look at averages. We just really did counts. And so that's cool. We can look at some new stuff here. And so we're getting the length of the passwords, right? And so what we can do is just append to this the stats command, because we have access to this length variable, or this length, field or column. And so we can just run the average command, which is going to average out all of these different lengths here into, what they, average out to. Math is hard. And so I'll just, put in the length field here that we're feeding into the average function, and we should be good to go. That should be it. Yeah, okay, and so we're getting 6.17433, whatever. So I think they asked for the closest whole integer. And so, yeah, so it should just be 6. Yep, there we go. Cool. All right, next question. How many seconds elapsed between the time the brute force password scan identified the correct password and the compromised login? Okay. For this, it's asking us, I think, the time that is elapsed or passed between the discovery of the correct password and the first successful authentication. And so, we know that Batman is the correct password, right? And so let's add on to our previous search where we built out the table. And I think we can just leave length. I don't think it matters. And so what I want to do here is inject a sub-search. I guess after this is fine. And I just want to search to equal, where the password field, if I can type, equals Batman. And I think, okay, yeah, so we're getting 2 results. And yeah, so it looks like this was the earliest one. So that's weird. So I guess they discovered the password earlier on in the brute force and then decided to log in as it later on. Maybe from a different IP or something. Okay, so, well, these are the 2 timestamps. And so what we could do is just copy these 2 timestamps and use some sort of site to, find the difference between them. That's pretty trivial. However, what we could also do is there is the transaction command. And so what I can do is just pipe this over to transaction. And this command is just going to tell us information about the 2 different entries. And so in this case, the duration of time that elapsed between them. And so the actual field here I want is password. And we can see a bunch of new fields have been added. So we can see things like the field match sum and the line count. But we can also see the duration, which is the time elapsed between the first and last entry. And that's going to be 92.169084. So 92 dot, what is it, 16? No. I think maybe this eval statement is throwing us off. No. And I think it's because I don't know how to read, and we need to round this up to the nearest decimal place. Okay, that's why. I really need to read these. All right, last question here, aside from, the 2 that I don't think we should do at this moment, but how many unique passwords were attempted in the brute force attempt? Well, this one's pretty easy, right? So let's back this up a bit. And what we don't need here is this. We don't need the transaction. And we don't need this search command here to pull back, we want to pull back everything, basically. However, it's asking for unique passwords. And we did have multiple, Batman passwords. And so what we can do is, I'm going to take out the length. We don't really need this. And under our table here, I want to run the dedupe command. And run that against our password field to clean up any unique entries. Or any duplicate entries. And then run stats count. And run that against password. We should get the count of all the individual passwords. So what we can do now is just use the stats sum to add these all up, right? To add all of this count up. And then throw in the actual count field, or the count column here, as the input, and we'll just call it count. Yep, there we go. So 412. So 412 attempts, and then there was that one successful login. Or 412 attempts, and then there was that one, duplicate login from when the attacker identified the password. So 412. And there we go. We are good to go here. And so that was quite the investigation, right? And so I hope you were able to follow along and, follow the different actions and correlation efforts that we performed. And I hope it made sense. And I think this was a really cool and diverse data set that honestly gave us a lot to work with. And you'll notice that we didn't get to touch on the syslog or win event logs yet. That's actually in the second scenario within this dataset, which traces a ransomware incident. And so I encourage you to try going through that one yourself and see how well you do. And so with that, thank you, and I will see you in the next lesson.